Alright, we got some food. We're good to go. Alright, let's tackle this next one. So, here's our function. Y equals 1 over x squared minus 3x minus 4. First thing we're going to do here is factor. That's the first step. And then identify asymptotes. Okay, so let's go ahead and factor this first. This will be 1 over x squared minus 3x minus 4. That's going to be x minus 4 times x plus 1. Identify asymptotes. Let's see, y can't equal 0. Okay, that's because we haven't shifted up or down at all in this function. We would have that plus k on the outside, remember. X can't equal 4. X can't equal negative 1. Those are our asymptotes. So I'm going to go ahead and graph those. 4, we have an asymptote right down there. Negative 1, I have an asymptote right here. And then I've got this horizontal asymptote here, y equals 0. So now I want to see what is the graph doing on the left side of this, in between it, and then on the right side. So these functions tend to follow a behavior that is up, down, up, or down, up, down, depending on the highest power here. Okay, so it all depends on the highest power. This is a squared function. It's a squared. The highest power is a square. It's a rational function. So this is going to follow in either up, down, up, or down, up, down. What do I mean by that? Okay, so what I'm going to do here is identify left of negative 1. That's our asymptote here. What's happening? And I just want to know what the nature is of the graph. Is it positive or is it minus? So is it positive or minus? I'm going to do in between the two asymptotes. Is that positive or minus? And then I want to do to the right of 4. Is that positive or minus? Doing it like this is going to save you a ton of time. You don't have to make a table. All you have to do is roughly compute what the function is for my values to the left of an asymptote, in between, and to the right. And this works no matter how many asymptotes you have. If you have 4 asymptotes, you'll have to do this 5 times. If you have 6 asymptotes, you'll have to do this 7 times. Computing is going to take you a long time, so this is just a way to give you a rough estimate. So if I'm left of negative 1, is it positive or minus? I'm just going to use the value of negative 2. So putting negative 2 into this function, negative 2 minus 4 is negative 6 times negative 2 plus 1. So that's a negative number times some negative number. I don't even care what it is. I don't need to know. Times 1 over negative 2 plus 1, that's another negative number. Well, guess what? A negative times a negative is a positive number. So we're looking positive here. Okay, so I can just go right in here and throw my curve in. I'm just kind of sketching. Okay, if I wanted to actually graph this, I would probably just use a graphing calculator. This is just a sketch. It's helpful in cases where you can't use a graphing calculator, so you don't have one, or say you can't even really plug in your function into the calculator. This will just give you a sketch. Okay, so that's one point. Let's select the next point in between negative 1 and 4. I'll plug in 0. 0 minus 4 is a negative number. 0 plus 1 is a positive number. Negative times a positive is a negative number. So it's negative. Okay, so this next part, so check this out. We have an asymptote here and an asymptote here. I'm a negative number, So I'm going to start out here at negative infinity. I'm going to get all the way up as close to that horizontal asymptote as possible and then go back down. Okay, so this is a negative number. The nature is going to be the same in between these two asymptotes. Now let's look right of 4. So let's plug in 5. 5 minus 4 is a positive. 5 plus 1 is another positive. Positive times a positive is a positive number. So our nature is positive. So we've just given a rough sketch of this function, real quick and easy. I'm going to go on to the next one. Alright, let's try this one. I'm going to pause the video, and then I'll see you guys soon.